Going to space is not expensive. It is very expensive. Sending a single kilogram of any material out of Earth costs approximately $4,000. This is just to put that 1 kilogram into orbit, not to reach the moon or explore the solar system. But merely leaving Earth is the main difficulty in space travel. If there were a cheap and simple way to leave the planet, space exploration would be changed forever, and maybe there is a way you will like. In the late 20th century, Russian scientist Konstantin Syok proposed an idea that seemed somewhat absurd at first, but actually has potential. The idea is to connect a cable from the Earth's surface to a heavy anchor in orbit precisely 35,786 kilometers high. This specific height is where the centrifugal force of orbiting around the Earth balances with the force of gravity. It's like the feeling you have when making a turn in a car. The centrifugal force generated by making a turn quickly pushes you against the car seat. What the anchor orbiting Earth at 3 kilometers per second would do is use this centrifugal force to keep the space elevator cable stretched and prevent it from falling back to the planet. Moreover, the orbit of the space anchor is a geostationary orbit that has the same duration as a day on Earth. So, besides keeping the cable stretched, the anchor will ensure that the cable does not tilt or change position relative to the planet's surface. With the anchor in place and a cable stretched from the surface to the anchor, all that would be needed to reach the desired orbit would be to climb the cable in the same way you climb a tall building using elevators. That's why this concept is called space elevators. On paper, taking things to Earth's orbit using a space elevator would be about 20 times cheaper than the traditional method of using rockets. The idea of a space elevator is somewhat absurd, but still, a space elevator, one of the futuristic technologies with the most potential, is not giving up in one way or another. Creating a fixed base for the cable on Earth and a cable for the elevator to ascend will require some creativity from humans, but there is no reason to think that this would be impossible considering the technologies we already have today. The main challenge here is how to supply power to the motor that will raise the cable. It's not possible to use an electric wire 36,000 kilometers long plugged into an outlet. The main solutions are energy transmission via laser or using an electricity cable of only 40 kilometers and using solar energy beyond that. For the space anchor, the best candidate for the space anchor would be to find a small asteroid and use it as an anchor. NASA has already diverted the orbit of an asteroid with the DART project, and recently the same technique could be used to make an asteroid stop near Earth. Fortunately, the necessary asteroid is small enough not to pose risks if it falls back to Earth. It would just evaporate in the atmosphere like many small asteroids and meteorites do every year. And no one cares. The only danger of structural damage to the space elevator is the cable breaking. Tightly stretched cables breaking can cause significant damage, and a 36,000 kilometers cable stretched by a 50-ton asteroid could cause quite extensive damage. The cable of a space elevator near New York could fall on South Africa, Madagascar, Israel, and England at the same time. In other words, an accident of global proportions. Therefore, we need to find some very resistant material for the cable. Its material needs to be 100 times more resistant than steel just to support its weight and the tension of being stretched by an asteroid in orbit. In addition to being able to withstand impacts from micrometeorites and all kinds of weather on the planet's surface. And that's where an issue comes in. No known material satisfies any of these conditions, perhaps. Not even supermaterials like nanocarbon fibers are capable of it. And this is the major problem in the path of the space elevator. If a material that serves for the cable were discovered, creating an elevator is an engineering question, not a science one. But this seems like a lot of work. Would it be worth it? A space elevator would make space travel inconceivably cheaper than with traditional rockets and open the doors of the solar system to humanity. Using numbers, with traditional rockets, sending a kilogram into space costs $4,000. With a space elevator, sending 1 kilogram to Jupiter would cost a little, more than $200, and Jupiter is quite far away. The trick is to use not only the height of the elevator, but also its speed to give that initial boost to the payload. This would make research and production of medicines and chemicals that need zero gravity cheaper. It would make launching satellites with all kinds of imaginable utility cheap, and more countries and companies than ever could have infrastructure in space. The low price of sending things into space would also make building the second express elevator cheaper, even difficult to conceive. Exactly everything that would be possible thanks to this. And even if creating a space elevator on Earth is impossible, there is reason to imagine one in our future. Creating an elevator on the moon could be extremely useful as a refueling point for explorations toward the depths of the solar system. So, in one way or another, maybe the future of space travel is in elevators and not in rockets, even if that elevator is not on Earth. Thank you very much, and until next time.